Worlds we once knew as static, unchanging spheres are actually dynamic canvases, constantly rising and falling over eons. Planetary landscapes undergo radical transformations, erasing ancient features while forging entirely new geological marvels from their very core. Worlds we once knew as static, unchanging spheres are actually dynamic canvases, constantly rising and falling over eons. Planetary landscapes undergo radical transformations, erasing ancient features while forging entirely new geological marvels from their very core. Our understanding of planetary bodies reveals a universe teeming with geological drama, a ceaseless cycle of creation and destruction. These processes sculpt monumental mountains, carve colossal canyons, and even orchestrate the disappearance of entire oceans from their surfaces. Such dramatic changes across celestial bodies profoundly influence their potential for fostering life and maintaining stable environments. You see, every world, from scorching Venus to icy Europa, possesses a unique geological heartbeat, dictating its evolving appearance. Scientists have meticulously pieced together these cosmic sagas, unveiling the powerful forces that reshape planets across unimaginable timescales. Understanding these deep geological narratives helps us grasp Earth's own fragile stability and its place within the broader cosmic tapestry. It's a story of incredible forces, relentless erosion, and the persistent internal heat driving these profound transformations across the solar system. These epic sagas unfold with breathtaking scale, often involving events that completely resurface a world or strip away its protective atmosphere. We are witnessing, through scientific observation, the very pulse of planets, a testament to their vibrant, ever-changing nature. This journey will expose the stunning rise of colossal structures and the equally dramatic fall of entire planetary features. On Earth, plate tectonics orchestrates grand geological movements, where continental landmasses slowly collide, crumple, and uplift into towering mountain ranges. These immense forces, driven by the planet's molten interior, create majestic peaks like the Himalayas, constantly pushing skyward over millions of years. Yet even as mountains rise, the relentless forces of wind, water, and ice immediately begin their work of erosion, wearing them down. Imagine colossal rivers carving deep valleys through solid rock, slowly reducing once mighty ranges into gentle, rolling hills over geological epochs. But that's just one example of planetary transformation. Other worlds experience far more violent and sudden resurfacing events. Consider Venus, a world completely veiled by thick, toxic clouds, where geological evidence suggests periodic, catastrophic global resurfacing episodes. Vast lava flows engulf its entire surface, potentially erasing all previous geological features in a relatively short geological burst. Scientists hypothesize that Venus's lack of plate tectonics allows internal heat to build up until it escapes in massive, widespread volcanic eruptions.
This cycle of gradual heat buildup and explosive release effectively wipes the planet clean, creating a perpetually young-looking surface.
Explosive, however, landscapes isn't creating solely a heat from within. Surface external forces also play a crucial role.
On Mars, the colossal Olympus Mons, a shield volcano larger than Arizona, stands as a testament to immense, sustained volcanic activity.
Its incredible height, nearly 3 times that of Mount Everest, results from Martian crust remaining largely stationary over a persistent hot spot. Yet Mars also exhibits the dramatic fall through atmospheric loss, thinning its once dense atmosphere over billions of years. This atmospheric stripping allowed surface water to escape into space, transforming a potentially wet, habitable world into a frozen desert. And then something unexpected happened. The formation of Valles Marineris, an immense canyon system stretching thousands of kilometers across the Martian equator. This chasm, far grander than Earth's Grand Canyon, likely formed through a combination of tectonic fracturing and subsequent erosion by ancient water flows. We see the rise of volcanic giants and the fall of oceans, often driven by the planet's magnetic field or its absence. Io, one of Jupiter's moons, showcases extreme geological dynamism, constantly reshaped by powerful tidal forces from its massive parent planet. These gravitational tugs generate immense internal heat, driving hundreds of active volcanoes that continuously erupt, burying old landscapes under fresh lava. Eo's surface is therefore incredibly young, with craters quickly covered, exemplifying a rapid geological rise of new terrain and fall of old. Wait until you hear what comes next about the icy worlds of the outer solar system and their hidden geological secrets. Europa, another Jovian moon, exhibits a fractured icy shell, hinting at a vast, subsurface ocean kept liquid by similar tidal heating. Here, ice tectonics might operate, where plates of ice crack, converge, and subduct, creating ridges and smooth plains on its frigid surface. This constant churning of ice, though different from rock, represents a dynamic geological cycle of rising ice blocks and collapsing fissures. Scientists explore these deep cracks for clues about potential hydrothermal vents on the ocean floor, a source of energy for nascent life. Enceladus, Saturn's moon, actively blasts plumes of water vapor and ice particles from its south pole, revealing a subsurface ocean actively circulating. These geysers, rising hundreds of kilometers into space, represent a dynamic exchange between the moon's interior and its external environment. The constant emission of material slowly reshapes Enceladus, a subtle but persistent geological transformation driven by internal heat and tidal forces. Even airless bodies like our moon show evidence of ancient geological activity, with vast lava plains, like craters mostly preserved, filling ancient impact basins. These dark plains represent a period of volcanic rise, covering earlier, heavily cratered surfaces, a form of geological resurfacing from long ago. But the absence of an atmosphere and internal heat means erosion is minimal, leaving those ancient falls, like craters, mostly preserved. Tidal interactions can also drastically influence a moon's geology, sometimes stretching it thin or even tearing it apart. Imagine a moon like Phobos, slowly spiraling inward towards Mars, destined to be ripped apart by gravitational forces, forming a temporary ring. This dramatic fall of a celestial body demonstrates the ultimate consequence of immense gravitational power over geological structures. The rise and fall narrative extends even to comets, which erode dramatically each time they approach the sun, shedding vast amounts of material. Each pass diminishes their icy bodies, a continuous geological fall, until they eventually disintegrate or become inert, rocky remnants. Understanding these diverse mechanisms across the solar system unveils a universe far more active and destructive than once conceived. From towering volcanoes to disappearing atmospheres, the stories of planetary rise and fall are written in the very fabric of these worlds. What will happen to Earth's grand mountains and deep oceans as these immense geological cycles continue their relentless march forward? The answer lies within the planet's core, the engine of its dynamic surface, slowly cooling over billions of years. These planetary transformations hold profound implications for the search for extraterrestrial life, guiding our exploration efforts to promising locations. A world with active geology, like Earth, often possesses a dynamic environment capable of recycling nutrients and maintaining a stable climate. This geological activity, the engine of rise and fall, is frequently linked to the presence of liquid water, a key ingredient for life. Worlds like Europa and Enceladus, with their subsurface oceans and active geology, become prime targets for future missions seeking microbial life. However, too much geological activity, like on Io or early Venus, can create environments too extreme for life as we know it. The balance between creation and destruction is delicate, a cosmic tightrope walk that determines a planet's long-term habitability. Learning about these processes elsewhere helps us better appreciate Earth's unique geological history and its continued, delicate planetary dance.
Our blue planet, constantly reshaped by plate tectonics, maintains a relatively stable climate due to the recycling of carbon and other elements.
Without this climate, due to the recycling of carbon and geological rise and fall, Earth might have become a barren, lifeless world, much like its less fortunate planetary neighbors. It underscores how critical internal heat and active surface processes are for fostering and sustaining complex biological ecosystems over vast time. These insights also inform our understanding of exoplanets, helping scientists predict which distant worlds might possess similar dynamic geological cycles. By studying the geological evolution of our solar system, we gain a universal framework for understanding planetary destinies everywhere. It's a humbling perspective, revealing that even seemingly permanent mountains are transient features on a cosmic scale, eventually succumbing to erosion. The ongoing story of planetary rise and fall reminds us of the universe's incredible, relentless power and its capacity for constant renewal. Every crater, canyon, and mountain tells a deep story of these dynamic forces, silently shaping worlds across the cosmos. From Earth's shifting continents to Venus's global resurfacing, the rise and fall of planetary landscapes is a universal, fundamental geological truth. If you found this cosmic ballet fascinating, subscribe for more incredible stories like this, and tell us which planetary transformation amazed you most. Join our journey of discovery as we continue to unveil the universe's most captivating secrets, one breathtaking landscape at a time. If you found this cosmic ballet fascinating, subscribe for more incredible stories like this, and tell us which planetary transformation amazed you most.